In this video, I'm going to talk about the second example of simplifying the irrational expressions right over here. And the question is, simplify these rational expressions. So negative 15 times k squared over 15 times k to the third power plus 45 times k squared. And before I solve this question, I want to talk about one thing that people are usually confused with. Well, people think that, well, we can simplify 15 times k squared in the numerator and 50 times 15 times k to the third power in the denominator, but we can't. Actually, there's a brackets in the denominator, but we're not using it in the question for the convenience. So if you simplify this rational expression a little bit more, I'll write this down again. So the question is negative 15 times k squared over over 15 times k to the third power plus 45 times k squared. And I'll use brackets in the denominator to not to be confused with the numerator a little bit. So let's simplify it. And we learned that in order to simplify this expression, we need to pull out we can say the greatest common division into the of these nomials. But if you look at the numerator, we can simplify the denominator because there are more than two terms. But when you look at the denominator, there's only one term, so that means we cannot find the common. We cannot find the common division, so we have to leave the numerator, and we can simplify the denominator. So if we simplify furthermore, so it's equal to we'll just leave the numerator, so negative 15 times k squared, and over if you simplify 15 15k to the third power, if you think about the greatest common division, let's think about it a little bit. So I'll write it here. So 15 times k to the third power, and then 45 times k squared. If you look at, we can only simplify into like terms. So if you look at the numbers, so 15 and 45, it is both divisible by 15, so I'll write 15 right over here. And then if we divide it by k squared, which is the greatest common division of k squared, so if you look at it, it will be k squared. So I need to write down more. 15 times k squared times, right over here, if you pull out 50k squared from this number, it will gonna give us k, just k. And then plus 45 divided by 15 is just going to be equal to 3, and k squared divided by k squared will just going to be equal to 1. So the greatest common division is equal to k plus 3 times 15 times k squared. But we need to know that we just simplified. If we multiply by using the distribute property, we're gonna get this term right over here again. So if you write this in the denominator again, so right over here, so negative 15 times k squared over 15 times k squared times k plus 3. Then we can simplify 15k squared and 15k squared to both sides. So 15k squared and 15k squared, but we need to be careful here. Usually people think that if we divide 15k squared and 15k squared, well, there will be a 0, but it's wrong. Actually, it is actually negative 15k squared times 1, but we're not multiplying 1, because if you multiply 1, it will just gonna give the answer. So it will gonna be, if you simplify, gonna be 1. But we need to be careful with the negative or positive signs. So we're going to be negative 1. So I will write this down again right over here. So it is equal to -1 over -1 over k plus 3. And we have simplified the expression right over here. And this is the simplified version of this original expression right over here, algebraically. And so, before we finish this video, I want to talk about what value of k we're gonna make this expression undefined. Well, we know that the value that makes the fraction undefined is when the fraction denominator is equal to 0. So I'll write when denominator is equal to 0. So with using this thing right over here, we can say that, well, k plus 3 should be equals to 0 when it and the k value, if you find the k value, if you input k value into denominator, it will make it into undefined. And we can subtract 3 to both sides, and we're going to leave us k is equal to -3. And we're done. This was the second example of simplifying this rational expression.